Hello. Okay, hello, welcome to day, honestly, this is tricky for me too. Day 7 is what we're doing today. So day 7, so let me give you a timeline for, if you see this later. Generally, the first stream we did was day 1 and 2. Then, the second stream was day 4 and 5. Yesterday I did day 3, and today I'm doing day 7, because I'm intending to do, let me look at my notes here. Days, where is my little notepad? Is it in this one? I'm going to try to do day 6, 8, 10, and 15 in one stream tomorrow. So after that, I'll be doing whatever is left of what I didn't manage to do, as well as the days that are in between that. Why am I doing that? Because they all essentially have the exact same... Oh, let me just turn that music down a tiny bit. It's a bit much. Here. Why am I doing that? Because the 6, 8, 10, and 15, at least up to right now, are all Windows boxes that we cannot really properly complete. Like I mentioned this in the day 3 video as well. They have very different topics, but they have a very similar accessibility blocker that we literally just can't really work around. It's all PowerShell commands, so in theory, yes, you probably can, if you can get command line access somehow, and there's probably some Metasploit way of doing that, but we're technically not allowed to even cheat with these boxes. We're supposed to do them as they're given to us, and we're already stretching that a tiny bit by what we're doing today, so I don't want to go too far away from what they're intending for us to do, and that means that essentially these 4 days are pretty much barred to us until we get someone to finally go in there and fix the templates, which hasn't happened yet. So that's fun. That's perfectly great. Yeah, that's why I'm doing them in such a weird order. Today's 7, yesterday 3, tomorrow 6, 8, 10, 15. I'm hoping I can knock those all out in one stream. That will be really nice, because obviously I'm a little behind on all these, and I think after today's video, I'll upload 3 and 7. So I'll at least have 1, 2, 3, 4, 5, 7. And tomorrow's 6, 8, and 10 should join. And then we can do 9, 11, 12, 13, 14, etc. in subsequent videos this week. And hopefully by the time I've done all those videos, we'll be caught up. And we can do maybe the last few ones on stream next week. That'd be cool. Because that is the 24th, if I'm not super mistaken. I'll have to see. But yeah, that would be really cool. We'll have to see how that progresses. For now, though, let's go do number 7. That means the music goes away. Bye, music. Let me find the Chrome right now. I think we have a Family Guy tab on the screen. I hope you like that. Here's Try Hack Me. There you go. Well, what was that actually showing? Let's see. Just these two is talking. Okay, well, there's 2 guys talking about Family Guy. Oh, there you go. That was a video that we had on the screen for a bit there. This is the tab in question, the one that we actually want. I did not clear out my YouTube before I should have did this. You know what? Let's actually do that real quick and just make sure that... Actually, nah, it's fine. Yeah, if I'm doxing myself, whatever. At this point, I guess I'm too late anyway. I don't want to start recording this again, so screw it. If I dox myself, oh well. Blindly Coding is the channel that this is going to be uploaded on, so you're not learning anything there. And I guess you now know that I sometimes watch Family Guy content. Oh, good for you. Let's scroll down to the right day. This is, oh god. Here we go, day 7. Let me see where the speech is going. Speech is going to me, not to you. Let's fix that over. And we'll slow the speech down for when it actually becomes relevant, which it hasn't yet. Let's turn the speech rate down a tiny bit, and we can start with this story for today. Do I still have my elf voice? Hello! Yes, I do. I don't think I'll need it today, but who knows. All right, let's go. This story... Oh, the date. I should read the date first. Task. Okay, day 7, task 13, AWS log analysis. Oh no, I'm speaking in CloudTrail. What? I feel like that's some kind of reference. I don't know what it is. This story. Task banner for day 7 graphic. As Sockmas approached, so did the need. So to provide those without with something to read. Blong. Care.wares tried, they made it their mission. A gift for all wares, a Sockmas tradition. Although they had some, they still needed more. To pick up some books, they'd head to the store. The town's favorite books would no doubt make them jolly. They ticked off the list as they filled up the trolley. With the last book ticked off, well, so what you do to the book? What you take it off for? With the last book ticked off, the shopping was done. When asked for their card, the ware handed them one. I'm sorry, he said as the shop clerk reclined. I can't sell you these books as your card has declined. Declined what? I think you'll find it has been declined. Good sir. The ware put them back as they walked in confusion. How could this be? An attack? An intrusion? And when they logged on to where the ware got us scared to find the donations they wished weren't there. We have an image with the alt text where buying books image. Okay, we'll click away to walk through because we don't want to see that just yet. I don't think we'll need it today. We'll see. The heading says monitoring in an AWS environment. Care.wares infrastructure runs in the cloud, so they chose AWS as their cloud service provider. CSP. Okay, we're not explaining AWS. AWS stands for Amazon Web Services. Instead of their workloads running on physical machines on premises, they run on virtualized instances in the cloud. These instances are, in AWS, called EC2 instance, Amazon Elastic Compute Cloud. So E and then C2 as in there's two C's. I'm not sure if that's supposed to be pronounced EC2 or EC squared, but I don't know. A few members of the Wareville SOC aren't used to log analysis on the cloud, and with a change of environment comes a change of tools and services needed to perform their duties. I haven't been properly talking into the microphone this entire time. You'll be okay. Their duties this time are to help care for wares. Oh, that's what it says. I thought it said care.wares, but it says care for wares. Figure out what has happened to the charity's funds. To do so, they will need to learn about an AWS service called CloudWatch. CloudWatch. Okay, this one doesn't use headings. That's annoying. So I'm gonna have to be able to. I'm gonna have a bit of trouble to figure out what we're doing after this. AWS CloudWatch is monitoring and observability platform that gives greater insight into our AWS environment by monitoring applications at multiple levels. CloudWatch provides functionalities such as the monitoring of system and application metrics and the configuration of alarms on those metrics. For the purposes of today's investigation, though, we want to focus specifically on CloudWatch logs. Running an application in a cloud environment can mean leveraging loads of different services. For example, a service running the application, a service running functions triggered by the application, a service running an application backend, etc. This translates to logs being generated from loads of different sources. It says lots, I just like saying loads more. CloudWatch logs make it easy for users to access, monitor, and store the logs from all these various sources. A CloudWatch agent must be installed on the appropriate instance for application and system metrics to be captured. A key feature of CloudWatch logs that will help the Wareville SOC squad and us make sense of what happened in their environment is the ability to query application logs using filter patterns. Here are some CloudWatch terms you should know before going further. Log events. A log event is a single log entry recording in an application event. These will be timestamped and packaged with log messages and metadata. Log streams. Log streams are a collection of log events from a single source. Log groups. Log groups are a collection of log streams. Log streams are a collection of are collected in a log group when logically it makes sense. For example, if the same service is running across multiple hosts. Well, now we know that. Cloud Trail should be a heading, is not a heading. CloudWatch can track infrastructure and application performance, but what if you wanted to monitor actions in your AWS environment? These would be traced using another service called AWS Cloud Trail. Actions can be those taken by a user, a role, granted to a user giving them certain permissions, or an AWS service, and are recorded as events in AWS Cloud Trail. Essentially, any action the user takes via the Management Console or AWS CLI, command line interface, or service will be captured and stored. Some features of CloudTrail include list always on. CloudTrail is enabled by default for all users. JSON formatted. All event types captured by CloudTrail will be in the CloudTrail JSON format. JSON stands for JavaScript Object Notation. It's essentially a way to make data JavaScript friendly. Event history. When users access CloudTrail, they will see an option, Event History. Event History is a record of the actions that have taken place in the last 90 days. These records are queryable and can be filtered on attributes such as resource and type. Okay. Trails. The above-mentioned event history can be thought of as the default trail included out of the box. However, users can define custom trails to capture specific actions, which is useful if you have bespoke monitoring scenarios you want to capture and store beyond the 90-day event history period. Deliverable. As mentioned, CloudWatch can be used as a single access point for logs generated from various sources. CloudTrail is no different and has an optional feature enabling CloudTrail logs to be delivered to CloudWatch. JSON rain image. Ah yeah, that's a fantastic alt text. I know exactly what this is for now. Thank you. As mentioned, CloudTrail helps capture and record actions taken. These actions could be interactions with any number of AWS services. For example, services like S3, Amazon Simple Storage Service, used for object storage, and IAM, Identify and Access Management Service, can be used to secure access to your AWS environment with the creation of identities and the assignment of access permissions to those identities. Will have actions taken within the services recorded. That's a very long sentence. Holy f***ing shit. These recorded events can be very helpful when performing an investigation. A heading! Oh my god! Intro to JQ. Alright, what is JQ? Earlier, it was mentioned that CloudTrail logs were JSON formatted. When ingested in large volumes, this machine-readable format can be tricky to extract meaning from, especially in the context of log analysis. The need then arises for something to help us transform and filter that JSON data into meaningful data we can understand and use to gain security insights. That's exactly what JQ is and does. Similar to command line tools like sed, awk, and grep, JQ is a lightweight and flexible command line processor that can be used on JSON. An image with the alt text Cloud JQ investigation image. How can it be used? Now, let's take a look at how we use JQ to transform and filter JSON data. The wares being the wares, they stored their shopping list from the trip to the bookstore in JSON format. Let's take a look at that. There's a JSON object which has a, let's see. Every key seems to be a book. The first one has book title Where's Wally, and Where's is spelled W-A-R-E-S. Very funny. It's written. It's a genre of children's book. It has 20 pages. Next one. Charlotte's Web crawler. Genre says young wear. Page count says 120. Third book, Charlie and the 8-Bit Factory. Young wear, and it has 108 pages. And we have The Princess and the Pea Cap. Again, children, and 48 pages. Another one, The Lion, the Glitch, and the Wardrobe. Very good. Okay, 218 pages. That's the whole thing. JQ takes two inputs, the filter you want to use, followed by the input file. We start our JQ filter with a, what's that?
Space.
With a period, which just tells JQ we are accessing the current input. From here, we want to access the array of values stored in our JSON with the left bracket and right bracket. And let me really quickly set my Braille to something that's not ancient Egyptian, so I can actually read it properly. Because I constantly have to check what I'm actually looking at here. There. Hey! It didn't do it right, hang on. Output. English 8 dot. There we go. Yeah. We want to access the array. So the thing in, it says left and right bracket. Fair enough, that's an array. And the JSON has like one array within its left and right curly brace, which is usually what it uses to denote objects or subkeys and things like that. So making our filter a dot, left bracket, right bracket. For example, let's run the following command. JQ syntax. Okay, we have a little prompt here that shows JQ quote dot left bracket right bracket quote, and then the file book underscore list.json, which pretty much shows us exactly what we just saw, but everything is now a key instead of an array. So before it was like one key that had an array in it of books, and now every book is its own key. If that goes over your head, you're not missing much. It's just the way JSON works. I'm sure there's like free Code Camp or Code Academy lessons on this if you're curious. Pretty much it just means that instead of having everything be one blob, we can now reference these individually, which is probably what they wanted to show. So we'll just go through. Now it says, once we've accessed the array, we can grab elements from that array by going one step deeper. For example, we could run this JQ command. The same thing, except what they've done now is they've added a bar.
Space, bar.
A vertical bar, which says, I guess, the next filter, another dot, and then book underscore title. And then we close the quotes after that. So the entire filter condition goes in quotes. And we put the bar and then book underscore title. I'm guessing that would show only the book titles. If we wanted to view all the book titles contained within this JSON file, this would return a nicely formatted output like this. Where's Wally, Charles Web Crawler, pretty much the titles I just mentioned, but only the titles. You don't see brackets anymore, there's no commas, no other information, just the titles. That's a lot nicer to look at, isn't it? I don't know, okay, I'm blind. It gives you an idea of what JQ is and what it does. Of course, JQ can filter and transform JSON data in many additional ways. In our upcoming investigation, we'll see the tool in action. The peculiar case of care for wearers' dry funds. Well. Now that we have refreshed our knowledge of AWS CloudTrail and JQ alongside McSkitty, let's investigate this peculiar case of care for whales' dry funds. Dry funds is an interesting term here. Also, I didn't know about CloudTrail before, so I'm not refreshing my knowledge. I'm literally learning as we go. The responsible wear for the Care for Whales charity drive gave us the following info regarding this incident. We sent out a link on the 28th of November to everyone in our network that points to a flyer with the details of our charity. The details include the account number to receive donations. We received many donations the first day after sending out the link, but there were none from the second day on. I talked to multiple people who claimed to have donated a respectable sum. One showed his transaction and I noticed the account number was wrong. I checked the link and it was still the same. I opened the link and the digital flyer was the same except for the account number. McSkitty recalls putting the digital flyer, Wareville bank account QR.png, in an Amazon AWS S3 bucket named Wareville-Care for Wares. Let's assist McSkitty and start by finding out more about that link. Before that, let's first review the information that we currently have to start the investigation. 1. The day after the link was sent out, several donations were received. Since the second day after sending the link, no more donations have been received. 3. A donator has shown proof that his transaction. It was made 3 days after he received the link. The account number in the transaction was not correct. 4. McSkitty put the digital flyer in the AWS S3 object named Wareville-bank-account-qr.png under the bucket Wareville-care for wares. 5. The link has not been altered. Okay, so this is going to be very fun. If the flag is in the PNG, we're not going to be able to find it. It's going to be that. It's going to be a thing. I think it might just be one of those ones. I'll be much amused if that's the case. I really will be. Okay, so connection details. Now that we have enough information, let's start the attached virtual machine in this task by clicking the Start Machine button below. Note that this machine may take 3 to 5 minutes to initialize. Start machine. Alright, the machine is starting. We get an ominous beeping sound to tell us that. The machine will start in a split screen view. If the VM is not visible, use the blue Show Split Split Blabba. We'll use the blue split screen. Use the blue Show Split View button at the top right of the page. Okay, we have an image with the alt text connection card for day 7. VM in split screen. Not great, not terrible. At least we know something odd happened. Oh dear, we have a heading, glitch did it. Let's examine the CloudTrail logs related to the Wareville-Care for Wares S3 bucket. For a quick example, a typical S3 logs entry looks like this. Fuck ton of JSON. I'm sorry, I'm not going to read that entire thing. It's a whole lot of JSON! It's a whole lot of JSON. We're not doing JSON today. It's too much JSON, we're not doing JSON. But yeah, there's a whole bunch of stuff in here. There's response elements, there's additional event data, there's a bunch of keys. A very long string that says XAMZ-ID-2. We're not going to read all that out loud. There's a lot of stuff here. And there's a request ID that we can look into. There's an event ID. There's a read-only that's set to true. There's a resources key that has stuff in it. That has type. It has an ARN prefix, whatever that does. The beeps will stop soon, by the way, if you're worried about that. Account ID, type, all the things. Okay. So let me just scroll past all this. It may be overwhelming to see that... I actually didn't let this beep out for a second so I'm not interrupted. Beep. Doop. 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 There we are. Boom. Alright, the machine is up. We'll be needing that in a while, I'm pretty sure. Overwhelming. Overwhelming. It might be overwhelming to see the sheer amount of information in one event, but there are some elements that we can focus on for our investigation. A table has a column field and a column description. I'm going to read them one after the other. User identity. Details of the user account that acted on the object. Event time. When did the action occur? Event type. What type of event occurred? E.g., AWS API call or AWS console sign-in. AWS service event. Event source. From what service was the event logged? Event name. What specific action occurred? For example, list objects, get bucket object, etc. Source IP address. From what IP did the action happen? user agent. What user agent was used to perform the action? For example, Firefox, AWS, CLI. Request parameters. What parameters were involved in the action? For example, bucket name. It's the whole table. By using the guide above, we can read the example log entry as follows. The IAM user, whereville_collector, listed all objects, list objects event, of the S3 bucket named AOC-CloudTrail-Whereville. The IP address from which the request originated is 34.247.218.56. The user agent indicated that the request was made using the AWS SDK tool for Go. Now that we know where to look, let's use JQ to filter the log for events related to the Whereville bank account qr.png S3 object. The goal is to use the same elements to filter the log file using JQ and format the result into a table to make it more readable. According to McSkitty, the logs are stored in the home/whereville_logs directory. To start, click the terminal icon on the desktop and enter the shown two commands below. We cannot do that. Or well, we can, technically, but it'd be very painful to do. So we're going to have to do some pre-hacking here so we can actually do the task. You might recall this from day 16 of last year's Accessibility Showcase for AOC, where I did the exact same thing I'm going to do now. We have to go to the machine for a bit. It's right here. So I'm going to, at this point, turn on the speech because it's a bit of a hoot. So here we go.
Speech mode top. Graphic. Edit multi-line. THM browser-based document.
We're first going to have to OCR the DHM browser-based frame.
Recognizing result.
And find terminal.
Ubuntu's home. Terminal.
There it is. We now have to move our mouse to the terminal and click twice.
Left click. Edit multi-line.
We need to check our work to see if we're actually in the terminal.
THM recognize applications places Ubuntu at try.
That tells me Ubuntu at try. Hackney tells me we are indeed in the terminal. Now, in this we are lucky. I did pre-test this before we started the video because otherwise I would have had to lump this one in with the one we cannot do. But the sudo counter, fortunately, is still running, so we can become root. If we now do that same thing, we scan the OCR the frame again, it should now say root at tryhack.
Record applications place root at tryhack /home/Ubuntu.
Very good.
Edit multi-line.
So, first thing we need to do, I'm going to just naively assume that SSH is not running. So we're going to start SSH up as systemctl start SSH. Note that I'm not seeing what I'm doing currently. I'm guessing. I have no idea what's going on. I'm just hoping that what I'm doing is actually working. Note that also the blip 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 in the terminal isn't working on this machine. Not sure why. Usually you can hear that at least. But that appears to be gone as well. So that's great. We no longer need to be root. We need to be Ubuntu again. So we're going to go to Ubuntu. Where are we? Let's have a look if we can see what directory we're currently in.
Speech mode. THM record Ubuntu at file edit view Ubuntu at system start exit Ubuntu at try $/home/Ubuntu.
Okay, we're in our user folder. That's exactly where we need to be. Very good. I'm going to go into the .ssh directory, and we're going to open the file authorized keys because we need that opened. Let's see, did that work? Oh.
Speech mode talk.
I may have just typed. I need to cancel this.
No
Stop.
Caps lock off. F.
No.
ANO. SPAUTORZED line KYS. Out. Record application Ubuntu file edit view new authorized keys. New nano 7 point author SH or SSH or
Looks promising. There's already a public key in here. That's very nice. It's not our key though. We now need to make sure they're actually at the very bottom of this file. We cannot verify that's the case, so we have to go way further than we actually normally would. Just hammer the right and down arrow. It's the only real way to do it. We cannot check if we're doing it right. Hit the end key a few times, maybe, then hammer enter a few times. Okay. At this point, I'm going to have to find my public key. Just going to quickly grab that. id_rsa.pub. You guys can't see this, but I can, so that's fine. Grabbing it from my notepad window here. Going back to the thing here, I'm going to paste this. Because I don't know if it actually pasted with Control-V, we're going to do Control-Shift-V as well, just in case. There. Now we're gonna save. We're gonna hit yes. We're gonna hit enter. We should now no longer be in Nano. Is that the case?
Applications Ubuntu file edit Ubuntu system exit Ubuntu
Looks right to me.
Slimon 6 Ubuntu try /ssh dollar Ubuntu try /ssh dollar nano authorized keys.
Yeah, we seem to be fine. So at this point, I have added my public key to the Ubuntu user on the SSH machine on this particular thing. So if I close out of this and go up to the top, we look at what the target IP is. The target IP for me in particular currently is 10.10.11.41. So if I go up to my command line here, just open a Windows terminal window here. There's the Windows terminal. Now we go to SSH Ubuntu at 10. Whatever I just said. 10.10.11.41. 10.10.11.41. Now with a little bit of luck, we'll get a fingerprint warning.
The authenticity of host 10.10.
We did. And now if I say yes,
warning permanently added 10.10.11.41.
I have a shell. Very nice. So
speech mode off.
This is a way to get an accessible door into this task. I don't know why they don't just have SSH going on this machine, because it's not harming the integrity of the task. But it's very similar to last year's tasks where I've told them this too. I just had to do a whole bunch of fucking about, frankly, to make this task accessible. If you're a beginner, you've never done this stuff before, you would not know how to do what I just did. I'm going to see if I can get this window on the screen. I'll read the text out loud anyway, so I should be able to just leave it hanging on the command line for a bit. Let me see if we can get that working. I'm going to go to my properties here. I'm going to see if I can set this to the right thing. Windows terminal. There we go. Is it
list
working?
Sources window. Ops. Rec edit view. Row C. Row tool filter window scene. No. IC. No. Screencast face. Help. Window audio. Windows terminal.x. Ubuntu audio desk mix screen 47 scene transitions.
I am
window.
actually not super sure. Let me really quickly check with AI. This is the life of the blind content creator. Okay, and run. It goes boop, and it goes boop, and it's thinking about what I just asked it to do, and the response should be coming in any second now. It says the OBS preview is currently black, indicating that nothing is being. That's what I thought. So yeah, it's not doing it. Let's try a game capture instead. See, is that working? I should have tested this beforehand. Excuse me.
Game list sources window. Ops. Rec edit view. Row C. Proper sewer spool filters. Game scenes. Scene. No. IC screen face help. C. Ale right game capture.
Okay, well, if it doesn't work, it's fine. We'll literally just keep the thing on the Chrome. No problem whatsoever. I just want to make sure if you can get the command line, that'll be great. But if not, oh well. You guys are gonna have to do it the way I do it. And the screen is showing a command prompt. Perfect. You guys can see this as well as I can. Very nice. Okay. Well, this worked on SMU. Why it worked, but it did. Okay. So I will read from now on what we're doing. JQ. And then the word. Oh, what was that? You got a notification from Gmail. Gmail can wait. Gmail can wait. Alright, so where we were, when we left off, it says click the terminal icon on the desktop and enter the 2 commands below. So this is exactly what we just did, just blind friendly. So the commands it wants us to run is cd wherevil _logs. Let's go do that. Cd where tab, there it is. Very nice. And the next command is ls. All right, so we'll do ls. And we see there's a CloudTrail log.json and rds.log. And that looks to be it. Yeah, there's 2 files.
Speech CloudRail Ubuntu try CloudRail log.json rds.log. Ubuntu speech
Okay,
off.
I guess both of these will be useful in some kind of way. Alright, very good. With the commands above, we initially changed our career directory to the directory mxkitty mentioned via the cd command, and we listed the directory's contents using the ls command. As you can see, 2 files are inside it, but we will focus first on the CloudTrail log.json for this investigation. I find it very interesting that we don't explain anything about AWS, but we are explaining really basic Unix commands. That's just an observation. Now, let's start investigating the CloudTrail logs by executing the command below. Okay. We are running jq-r quote dot records bracket bracket bar select left paren dot event source equals s3.amazonaws.com and dot request parameters dot bucket name equals whereville dash care for wheres CloudTrail logs.json. If we run that command exactly as given, I will show and audio the results. Here we go.
Speech mode top paste. Event version 1.10. User identity type. I am. User principal is attack rocket 507 SKYSEJBQ ARM colon Oz colon I am colon 518,371,450,717 colon user slash glitch account is 518,307.
Oh, well, we're seeing glitch happen.
Speech mode
So
off.
that gobbledygook we just heard is a very good example of why I say for pretty much any tool you use in a blue team setting, you need to sort of figure out your own. Let's do this faster. Like essentially, I guess what you would do in this case is just filter by more parameters so you get less data back. But that's not what we're doing quite yet. So let's just see what they say here. Let's do a quick breakdown of the command we executed. Here we go. So jq-r filter. The -r flag tells JQ to output the results in raw format instead of JSON. Okay. Note that the filter section is enclosed with single quotes. Yeah, I said that already. The last part of the command accepts the input file, which is CloudTrail_log.json. .records instructs JQ to parse the events in the records container element. The records field is the top element in the JSON formatted CloudTrail log. So basically the way this works is you tell it, you give it a list of filters and you start from a certain point. It's almost like the root drive of your root directory of your hard drive. In this case, that's records, and then you go into a different folder and different thing and look for different things. Select event source equals S3 Amazon and uses the previous command's output and filters it on the event source and request parameters bucket name keys. The value s3.amazonaws.com is used to filter events related to the Amazon AWS S3 service, and the value whereville-care for wheres is used to filter events related to the target S3 bucket. Thank you for that information. As you can see in the command output, we were able to trim down the results since all of the entries are from S3. However, it is still a bit overwhelming since all the fields are included in the output. Now let's refine the output by selecting the significant fields. Execute the following command below. Okay, so in this case, we get jq-r records select event source equals s3amazon.com. And essentially the same thing as I said before, but now we're adding bar, left bracket, dot event time, dot event name, dot user identity, dot username, some random slashes, quote n, is that a, oh, that's a lie. So I think that's supposedly a new line character. Request parameters dot bucket name, and request name of dot key source IP n. Does that //n mean don't include this? Because that's kind of clunky the way it does it. Let me run that command first, and then we'll continue on reading what they have to tell us about it. So we have something on the screen that's new, basically. Here, all the things, here comes the command.
Speed 2024-11-2080-15-22-23Z. List objects. Glitch. Whereville care for wares. N/A 53.94.201.69. 2024-11-2080-15-22-25Z. List objects. Glitch. Whereville care for wares. N/A 53.
So what we could do here is not include the date field, because I guess there's way more information. I'm going to assume they're going to ask about the date field, which is why I left it in this time, but we could absolutely just not do the timestamp or put the timestamp at the end. Then again, this is command line output. We don't have a way to quickly skim through this. So even if you put it at the end, if you just let it ramble on like I just did, it'll still read those timestamps and be really in the way. So really what you'd need to do in this case is do screen review or something similar on your screen reader, and just ignore the last bit and then put the timestamp in the end, unless you need it, or just take it out entirely first. As you can see, we have adapted another pipe, added another pipe after, that's a bar character, after our previous filters. Let's discuss it quickly, okay? Command and description. So, event time, event name, user identity, user / n, blah, blah, blah. Yeah, same deal, so it's just one row, I think. The pipe filter uses the previous command's output and formats it to only include the defined keys, such as event time, event name, and user identity.username. The defined keys are enclosed with square brackets, left-right bracket, to process and create an array with the specified fields from each record. Note that the string / quote n/a is included purely for formatting reasons. This means that if the defined key does not have a value, it will display instead. I would rather it just do nothing at that point. I'm sure it's visually very handy to have that n/a. But it really just looked confusing to me. I wasn't really sure why that was there, so I might also just take that out for the next thing. All right. As you can see, I really start hating that phrase. I cannot see the results. I can perceive them. Like, I don't say the word perceive in that sense. I do say see, watch, and look, but this thing has said, like, as you can see, 4 times in the last 5 minutes, and it's starting to get a little annoying now. As you can see in the results, we could focus on the notable items, but our initial goal is to render the output in a table to make it easy to digest. Let's upgrade our command with additional parameters. Okay, what are we adding? We're adding, we're doing the exact same thing, except at the end. Let's see, what are we adding? Blah, blah, blah. We're adding bar at TSV. And then we're also doing a bar command for the entire JQ, which we are doing column T. Okay. So I'm going to copy paste. It could go up one in the history and do it that way, but I'm going to just copy the entire thing, because I'm going to have to like modify the end of that command anyway, and at this point, we might as well just do it all in one go. There we go.
Copy the Ubuntu.
So if we paste that in, it looks like this.
Event time, event name, username, bucket name, key source, IP, 2024-11, 2024-11-2080.
So yeah, right now what I could do is look at Braille display.
2024-11-2080, 15, 22, 2024.
I see a pre-request, I see a put object, I see a list object, and it looks like Glitch has been doing it all. So it looks like Glitch did it, which is probably the point I'm going to make. You may observe that we have added the following items to our command. Another table. Blah, 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 blah. That's not new. That's not new. Yeah, the new command prepends a column header row and is defined using square brackets since it is an array that corresponds to the selected field. That's cute. All right. Note that a comma is used before the select filter to combine with those of the select filter results we previously used. Okay. Then we have bar at TSV. Is that an at sign or a quote?
Out of space. At T.
At TSV. And then at the end of the quote. Apparently that means sets each array element, the output processed after the filters, as a line of tab separated values. So TSV stands for tab separated output. Very nice command. column T dash as T. Okay, what does that do? It takes the output of the JQ command, now resulting in tab separated values, and beautifies its result by processing all tabs and aligning the columns. So for a blind screen reader, you probably would not need that columns command. It's not really going to help you much. Note, our crafted command lets us summarize S3 activities from a CloudTrail log. Now that we have crafted JQ query that provides a well-refined output, let's look at its results and observe the events. Based on the columns, we can answer the following questions to build our assumption. How many log entries are related to the Wareville Carefulness bucket? Which user initiated most of these log events? Which actions did the user perform based on the event name field? Were there any specific files edited? What is the timestamp of the log entries? What is the source IP related to these log entries? Looking at the results, the log events seem related to the Wareville-care4wares bucket, and almost all are related to the user glitch. Aside from listing the objects inside the bucket, list object event, the most notable detail is that the user glitch uploaded the file wareville-bank-account-qr.png on November 28th. I saw that too, yes. This seems to coincide with the information we received about no donations being made 2 days after the link was sent out. McSkitty is sure there was no user glitch in the system before. There is no one in the city hall with that name either. The only person that McSkitty knows with that name is the hacker who keeps to himself. McSkitty suggests that we look into this anomalous user. McSkitty fooled us? McSkitty wants to know what this anomalous user account has been used for, when it was created, and who created it. Enter the command below to see all the events related to the anomalous user. We can focus our analysis on the following questions. What event types are included in these log entries? What is the timestamp of these log entries? Which IPs are included in these log entries? What tools and OS was used in these log entries? Here's another command. JQ-R. We're doing event time, event source, event name, username, source IP. And then we get the filters. Records, we do select user identity.username equals glitch bar, event time, event source, event name dot user identity.username, not or n/a, source IP or n/a, tab separated values, and we put it through that column thingy again. Long command. I'm going to paste it in just a second here. I'm going to see what that is all about. So here we go. Flop, flop.
Speech CloudTrail log.son column $T selected.
These get very long.
The results show that the CloudTrail log.
Very long
speech mode off.
Command. Here it goes. Whoom.
Speech 2024-11-20.
All right, let's see what
off.
the thingy here says. The results show that the user glitch mostly targeted the S3 bucket. The notable event is the console login entry, which tells us that the account was used to access the AWS management console using a browser. We still need information about which tool and OS were used in the request. Let's view the user agent value related to these events using the following command. Another stupid long command. I'm pretty sure all they do is add a user agent. So I'm not going to read the entire thing. I'm just going to paste it in there. And then we're going to see if we can figure out the results before they spoon feed them to us. So I see a user agent of Mozilla 5.0, Macintosh, Intel macOS 10.15.7, Apple WebKit 53736, HTML like Gecko, Chrome 129, Safari 537.36. I think that means it's Safari. It's Mac Safari. There are 2 user agent values included in all log entries related to the glitch user. Okay. S3 console /0.4 AWS internal. That's the SDK. Linux 5.10. OpenJDK. Okay, this is a Java tool. Very cool. Vendor, Oracle, yeah, whatever. This is the user agent string for the internal console used by AWS. It doesn't provide much information. And the other one that we just read, this user agent string provides us with 2 pieces of interesting information. The anonymous account uses a Google Chrome browser within a macOS system. Oh, that's what that means. Okay. So it's Chrome, but it's also macOS, so it has to put Safari in there. An experienced attacker can forge these values, but we should not dismiss this information. It can be valuable when comparing different log entries for the same user. We will park the current information for now. Let's gather more information to connect the dots. The next interesting event to look for is who created this anomalous user account. We will filter for all IAM related events. And this can be done by using the select filter.eventSource iam.amazonaws.com. Let's execute the command below and try to answer the following questions. What event names are included in the log entries? What user executed these events? What is this user's IP? Okay. Another stupid long jQuery command. jQuery. They should have called this jQuery, actually. That'd be funny. Now, JQ command. Essentially, we're looking at event. We're looking at event time, event source, event name, username, source IP, and then we're doing the filters that pretty much it just said that we were going to do. Yeah, we're going to paste this in and look at the information. One.
Speed bash at TSV cloud bash. Syntax error near unexpected token dot records.
I broke it.
Try hack. Out of list out of table dot event source. I Ubuntu a try dal JQ dash JQ Q J space J JQR event time events source dot event name dot user identity dot cloudrail log dot son column TS dollar T copy the Ubuntu a paste J event time event source event name username source IP 2024-11-28T15212126 ziam.amazonas.com list policies mixed ID 53.94.201.69 2024-11-28T152129 ziam.amazonas.com list policies mixed ID 53.94.201.69 2024-11-28T152130 ziam.amazonas.com list policies mixed ID 53.94.201.69 2024-11-28T152130 ziam.amazonas.com list policies mixed ID 53.
We keep seeing that same thing. So
speech mode off.
I'm sure there's more in there. We'll just let the hand holding continue. But this is why one of the reasons why speech is usually a lot faster than it currently is. There's just a lot of information to sift through. It says based on the results, there are many list policies events. By ignoring these events, it seems that the most significant IAM activity is about the user McSkitty invoking the create user action and consequently invoking the attach user policy action. The source IP where the requests were made is 53.94.201.69. Yeah, we saw that one a lot too. Remember that this is the same IP the anomalous user glitch used. Let's have a more detailed look at the event related to the create user action by executing the command below. Here's another one. JQ. Oh, no tables this time. Okay, JQ records. We're looking for event source iam.amazon.com and event name equals create user. Okay. Let's have a look what that brings up.
Speech mode bash Ubuntu a try slash paste
again.
bash syntax error near on.
Oh, Christ on a cracker. What do I do now?
Ubuntu a try slash whereville logs J JQ dot record select dot event name equals create user copy the Ubuntu paste event version 1.10 user identity type IAM user principal id adaptmkit 506Z6AZBXU6 ARN colon OZ colon IAM colon 518,371,400
Shush.
session credential from console true Client provided host header. iam.amazonas.com. SIF TLS cipher suite. TLS version. TLS detailed. Event category. Recipient accounted. 508 event category. Management. Risk management event. True. Event type. AOC call. Read only. False. Event ID. SID request ID. Create date. Oct 22 2024 320 ARN colon user id. Adactrimkit 5 username. Glitch. Path slash. User. Response elements. Username. Glitch. Request parameters. User agent Mozilla / source IP address 53.94.201.69 Oz region app southeast 1.
Looks good, right?
Event name create user. Event source iam.amazonas.event time 2020. Mfa authenticated creation date 2020 attributes. Session context. User access key username mixed ID. Ax accounted 500
Yeah, from what we can see here, it looks like Skitty made the glitch user, which is very odd. Based on the request parameters of the output, it can be seen that it was the user McSkitty who created the anomalous account. Now we need to know what permissions the anomalous user has. It could be devastating if it has access to our whole environment. We need to filter for the attach user policy event and uncover the permissions set for the newly created user. This event applies access policies to users, defining the extent of access to the account. Let's filter for the specific event by executing the command below. Here again, we are we're looking for the attach user policy event this time. For the rest, it's all very similar.
Speech, paste, bash, syntax.
I can never get this right the first time. It's very interesting.
JQ.records.event name equals copy to Ubuntu paste event version 1.10 user session client provides speech mode off.
Right,
speech TLS version event recipient accounted 5 management event type read only fall event request ID response elements null policy arn colon Oz username glitch request parameters user agent Mozilla source IP address Oz region apt event name attach user policy event source iam.amazonas event time 2020 file creation date attribute session contact username mixed ID access key accounted 5 arn principal id adapter type user identity event version 1 Ubuntu try
interesting. It doesn't really list the well, it lists an ARN, but what that means I don't know. McSkitty is baffled by these results. She knows that she did not create the anomalous user and did not assign the privileged access. He also didn't recognize the IP address involved in the events and does not use a Mac OS. She only uses a Windows machine. All this information is different to the typical IP address and machine used by McSkitty. So she wants to prove her innocence and asks to continue the investigation. Logs don't lie. I am getting beep beeps from my headphones, so give me just a second here while I attach my charging cable to the headset here. Otherwise we might lose power, and that would suck. There we go. McSkitty suggests looking closely at the IP address and operating system related to all these anomalous events. Let's use the following command below. The following command below, that's a circular circle. It's a double. Following command below to continue with the investigation. Okay, so what now? We're looking at event time, event source, event name, username, source IP is what we're grabbing. We're looking for source IP equals that event IP we just saw, the event time, and yeah, just everything. Okay, so we're just looking at that. Gotcha. Let's do our thing.
Speech mode source dot event name dot user identity dot username //n/a cloudtrail log dot son column $T selected.
Yeah, maybe I'm being a little bit lazy and just copy pasting these comments, which are stupid long.
Speech mode paste JQ event time event source event name username source IP 2024-11-28T15-2038 ZS3.amazonas.com head bucket mayor malware 53.94.201.69 2024-11-28T15-2212 ZS3.amazonas.com head bucket glitch 53.94.201.69 2024-11-28T15-2223 ZS3.amazonas.com list objects glitch 53. Speech mode off.
The very first log in this list seems to point to a certain malware. Based on the command output, their user account, McSkitty, glitch, and Mayor malware were accessed from the same IP address. The next step is to check each user and see if they always work from that IP. Let's focus on each user and see if they are always work from that IP. Enter the command below and replace the placeholder with the username. Okay, that means I need to copy this into a little notepad window first. And I think none of us need to be Sherlock Holmes to figure out that it's probably major malware that's doing this. Let's see. Username equals placeholder. We'll move placeholder and put mayor malware. How do you spell that guy's name? Let's see. Mayor malware, no capitals. Okay, that's what I did. Yeah, is that what I did? Is that even what I did though?
JQR event really? Time event source event.
No, I put a capital M for mayor, and that's probably bad. So let's make that a small M. Put
JQ,
this in
copy,
here. We'll put it in for performance's sake.
Speech paste event time event source event.
This is the mayor malware readout, and I think if we start continue reading, it'll say certain things. What is it gonna say? Let's focus on each user. Blah blah. We just did that. Blah 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 blah. While gathering the information for each user, we can focus our investigation on the following questions. Which IP does each user typically use to log into AWS? Which OS and browser does each user usually use? Are there any similarities or explicit differences between the IP addresses and operating systems used? Based on the results, we have proven that McSkitty used a different IP address before the unusual authentication was discovered. Moreover, all evidence seems to point towards another user after correlating the IP address and the user agent used by each user. Who do you think it could be? McSkitty has processed all the investigation results and summarized them below. The incident starts with an anomalous login with the user account McSkitty from IP 53.94.201.69. Shortly after the login, an anonymous user account glitch was created. Then the glitch user account was assigned administrator permissions. The glitch user account then accessed the S3 bucket named Wareville-care4wares and replaced the Wareville-bank-account-qr.png file with a new one. The IP address and user agent used to log into the glitch, McSkitty, and Mayor malware accounts were the same. The user agent string and source IP of recurring logins by the user account McSkitty are different. Definite evidence. McSkitty suggests gathering stronger proof that that person was behind this incident. Luckily, Wareville Bank cooperated with us and provided their database logs from their Amazon Relational Database Service, RDS. They also mentions that these are captured through their CloudWatch, which differs from CloudTrail logs as they are not stored in JSON format. For now, let's look at the bank transactions stored in the /Wareville log/RDS log file. Since the log entries are different from the logs we previously investigated, McSkitty provided some guidance on how to analyze them. According to her, we can use the following command to show all the bank transactions. Note: grep is the Unix command line utility used for searching strings within a file or an input stream. Okay, so we're giving a command here, grep insert rds.log. Okay. Let's run that so we have something to look at. Something pretty to look at. I guess these are SQL statements.
Speech paste 2024-11-28T14-2837.962Z 2024-11-28T14-2837.9629885Z 263 query. Insert into Wareville bank transactions, account number, account owner, amount, values 8839-22-19-13-29-69-17. Care4wares fund 638.99 2024-11-28T14-30 speech
okay,
mode.
So that's
speech mode
one
off.
event. If we look at this with Braille, it goes a little faster. We can see that the last entry was Mayor malware, and they got $322.10. So, oh my god, it might just be Mayor malware. Couldn't tell from the name or anything. From the command above, McSkitty explained that all insert queries from the RDS log pertain to who received the donations made by the townspeople. Given this, we can see in the output the two recipients of all donations made within November 28th, 2024. Redacted for brevity, thank you. Yeah, so for example, on 1522 at 1128, we had a query going to the account number what is it? 8839-2219-1329-6917. Care for Wear Funds 342.80. That's the one we just heard. And then there's another one. Let's see. That goes to a number 8839-2219-1329-6917. Still the same one. Then redacted. I'm guessing that's the question we need to answer soon. To Mayor Malware 193.45. Well. As shown above, the Carewares Fund received all the donations until it changed into a different account at the specific time. The logs also reveal who received the donations afterwards, given the account owner's name. With all these findings, McSkitty confirmed the assumptions made during the investigation of the S3 bucket, since the sudden change in bank details was reflected in the database logs. The timeline of events collected by McSkitty explains the connection of actions conducted by the culprit. We have a table that pretty much just summarizes the thing we've already summarized several times now, so I'm going to not read that again. I'm sorry. Answers the question below. What is the other activity made by the user glitch aside from the list object action? 1, 2, 3, 4, 5, 6, 7, 8, 9. I think you'll find that's put object.
Speech. Alert. Your answer is.
Yeah, we saw that when we were checking the first logs. What is the source IP related to the S3 bucket activities on this user glitch? It's the 69, the .69 one. This one. 5394.201.69. Okay, let's fill that in. Paste that in. I'm pretty sure that's the right one.
Speech. Alert. Your answer.
Yay.
Correct
Based on the event source field, what AWS service generates the console login event?
Answer format 6 star. 9 star.
Oh dear.
Mainland. Ubuntu star J.
Let's have a
Ubuntu.
look. Find that out. Can I get the entire log of this printed to the keyboard, please?
System menu. Set it. Close. Max minimize size. Move on the restore. Settings. Close C. Max minimize size on available S. Move on the restore R. Settings. Close C. Maximize on Ubuntu try it. / Wareville. Ubuntu try it. Run dial AOC text notepad. 53.53.
Oh dear.
Ubuntu 2024 2020. Event time, event source, C. Event source, IP. 2024-11.
Let's see what we got. S3, Amazon.
0.0412 vendor / Oracle 2024-11.
Sign in. Amazon aid. Yeah, I'm pretty sure that's right. Sign in at Amazon AWS.
Untitled notepad. Try act.
Sign in. AWS.com.
Try alert. Your answer is
Yay,
space.
we got it right. Okay, what's the next one? When did the anomalous user trigger the console login event? Dang it. So, let me see if I can really quickly get the entire contents of this somehow.
Speech tab unknown. Closest restore minimum system menu. No previous. Windows PowerShell terminal Ubuntu space. Ubuntu try it / Wareville log.
How did I do that again?
160.
Oh, like this.
106.
Control Shift A, I think, is select everything.
D.
Let's see.
Notepad. Windows PowerShell.
Perfect. Okay, so now I can actually look through these windows for these things. We're looking for console login.
Speech 2024-11.
It looks like it might be 2024 11/28 T 15/21/54.
Out of spelling error. Space.
I'm going to
2024
assume they
11.
want that entire string. So I'm going to copy that for
Ubuntu
now.
try.
Actually, let me switch
Ubuntu untitled no star JQ. C use
for the
speech
the
mode off.
visual people among us. Let me switch this back to where it was. We don't need the command line anymore. We need to see the questions. Let me switch it to the browser real quick. Here you go. So when did the anomalous user trigger the console log event? So the can I see the? Yeah, so it's colon 1, 2, 3 characters. Let's just paste this in, see if that matches. Colon 54Z. I think that's right.
Alert,
Yeah.
speech
So if you just want to type this over, it's 2024-11-28 capital T 15 colon 21 colon 54Z capital. What was the name of the user that was created by the McSkitty user? Huh? Glitch.
Speech. Alert, your answer. Speech mode off.
Very good. What type of access was assigned to the anomalous user? So we can go back into our thing. Let's have a look. Oh dear. Let's go in here. So that's the attach user policy event. This one. Attach user policy McSkitty. Yeah. Let's see. So we need to look at this thing. There's some kind of policy that they use, and we need to figure out what it was. So we got an event, user, type, I am user. Yeah, user McSkitty. User McSkitty, session context, attributes, creation date, we have that. MFA authentication false. We did not use MFA. That's a little suspicious already. Got the event time, event source. Yep, looks good. Event name attached user policy. Is region AP Southeast. Not sure where AP is. Source IP address, user agent. Okay. Just looking at what we're looking for here. Request parameters should be in here. Glitch, policy ARN. Policy/administrator access. Administrator access, I think, is the entire thing that they want. Administrator access, both A. Sometimes I forget to switch to the right screen reader mode, and then my cursor goes all over the screen. Very lovely when that happens. Yeah, I see no slashes in this, so I'm assuming they just want administrator access. Let's see if that's correct.
Try alert. Your answer is correct.
Did it right again.
Speech mode off.
Nice. Which IP does Mayor malware typically use to log into 8? Well, it's the same one that we already used, I'm pretty sure. The 69 one. $53.94.201.69. I'm pretty sure that's correct. I haven't really dug into the details we actually looked at for that particular thing, but I'm relatively sure
alert. Your answer is
that is correct. It is. What is XKitty's actual IP address? Oh fuck, we didn't look that up, did we? We did not look that up. We can though. Hang on. So that means we need to use that same key again. Except for the same command we used to put the placeholder name in, except this time we need to use McSkitty instead of what we were doing before. So let me do that. Can I? Yeah, there we go. Okay, so let's see. Their IP.
Speech mode 200 Ubuntu try 200 JQ command not found.
Try now.
Paste J event time event source event name username 0.1.15.79.
Looks like it's 31 210 1579.
1.2.13 space 3. Start mark 1.210 right 0 1 0 right point 1 left 1 5.7 not space. Copy to clipboard.
Don't know what
Run.
that was
Paste.
all
31
about,
points.
but we got it. Okay.
Space.
So this
31.
should
Copy.
be the correct
Star
string.
J2
I
hours.
just
Try
grabbed
me.
that from where we were in. Let's turn
Speech mode
speech
off.
off. Put this in here and...
Alert. Woo woo. Your answer.
Yay, we got it right again. What is the bank account number owned by Mayor Malware? That was redacted before, remember? Let's find that out. So that we need to find in the output that we've already seen again. We need to find the insert statement down here. Of course, at that point it says that I can't. Oh, I'm looking at the wrong file. My bad. Let's see. Insert. Yep. Let's find the right record here. Looking for Mayor Malware. Mayor Malware. This is the Careware Fund. I'm looking for Mayor Malware. Where is Mr. Malware? Hello, Mr. Malware. Hello, hello. Where you at? Here we are. No, that's still Careware. Scroll down. So many transactions. Scroll up a little bit here. We got Mr. Malware. There he is. 2394 69112 6912 7723 1294 is the address. This is the bank account number. I'm going to paste that in here. There we go.
Speech. Alert. Woo woo. Your answer. Speech
I
mode
did
off.
it right again. Want to learn more about log analysis and how to interpret logs, different sources? Check out the log universe room. We will, but not today. And we're done with day 7. Which means I can turn this video off now. Very nice. I'll do that. All right. Yeah, I'll have a good day. I'll see you in the next one. Or probably on the stream. We'll see. Bye.